Welcome to Module 2, Lesson 3. Today we're going to be going back and forth between numeric expressions and word expressions, and we're going to do that with the help of bar models in some cases. So this first problem, I have the sum of 8 and 7 doubled. So if I were to make a bar, a unit, that had a value of 8 plus 7, now I need to double that. Now I've got it doubled. That's what I'm trying to find out, question mark. And so my picture kind of tells me what I have to do. I have to take 8 plus 7 and then multiply that by 2. Here's another example. 3 times the difference between 37 and 5/10 and 24 and 5/10. So again, if I have my unit, that's going to have a value of 37 and 5/10 minus 24 and 5/10. And I want to do 3 times that. I need 3 equal units like that. And my answer is going to be those put together. And so I get an expression of 37 and 5/10 minus 24 and 5/10 times 3. I could also put the 3 times 3 in the beginning. It doesn't really matter. For the next example, the comparison bar model is probably more appropriate. We have the difference between 4 25s and 3 25s. So first I'm going to do my 4 25s. Each of these are 25. And I want to find the difference between that and 3 25s. Notice I'm lining up my equal parts. And what I'm trying to find is the difference, so trying to find what that is. You can see from the picture what it's going to be. It's just going to be 25. But as an expression, I'm going to have 4 groups of 25, and I'm going to take away 3 groups of 25. And if we want to put parentheses around those, we can, but we don't really need to. So that would be the numeric expression for that. Another type of problem you might be asked to solve is to take a numeric expression such as this and put it into a word expression. So I'm going to take the sum of 5 and 25, and then I'm going to multiply it by 12. So one important thing to remember is our order of operations. We're going to do parentheses first, then exponents, then multiplying and dividing are of equal importance, and we'll do those left to right, and then adding and subtracting are equal importance left to right. So the parentheses there tell me that I need to do this part, I need to do this part first, because the parentheses say do me first here. So anyway, there are multiple ways to express this in words, and there's a few ways that are just wrong. So one way I could do is this. I could say that I want to take 12 times what? 12 times the sum of 5 and 25. So that's one way I could do it. Here's a second way. This is not quite as elegant, not quite as nice an answer, but it works. I can say add 5 and 25, comma, then multiply by 12. That comma is important. It's telling me that this is a separate thing from this, as the parentheses show. Watch out for this answer here. This is absolutely wrong. A lot of people are tempted to just go left to right and read it as the way they see it. 12 times 5 plus 25. But if I take this quite literally, what I actually get is 12 times 5 plus 25, and that's going to give me an answer of 60 plus 25 equals 85, because this does not tell me to put the parentheses in. And since this doesn't tell me about the parentheses, then I need to follow our order of operations. Up here I'm going to get 30 times 12 which is going to be 12 times 3 is 36 plus a 0. Entirely different answer than that. So the last kind of problem you might be asked to do is something like this. That's compare two expressions without actually doing the math, without calculating the answers. So I have 18 times 27, and then I have 20 27s minus 1 27. So to compare these, to see which one's greater than, less than, or equal to, what you have to do is just think about what's going on. In this case, what I have here is I have 27 as kind of the common thing. So I have groups of 27s in both cases. In the first example, I have 18 groups of 27. So here's my 27, 27, dot, 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 27, 1, 2 groups, 18 groups. And in my second problem, I have 20 27s I'm starting with. So if I were to do something like this, 27, 27, dot, 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 27, 27, 27. There's one group, two groups, 18, 19, 20 groups of 27 that I started with, and I'm going to take away minus one of those 27s, just like that. And you can see here that I have one more group of 27 in the second one. So one more group of 27 is going to make that greater. Alligator eats the bigger number. And so that would be the answer. A bar model would show it here. You could probably do it with words as well. And that's all there is for today's lesson.